Good evening. This is Dr. Pradhan here. So, welcome to NPTEL project on econometric modeling. So, today we will discuss the same matrix approach to econometric modeling. So, in the last class we have given the basic framework of matrix approach to econometric modeling. So, that means how we have to use matrix to solve the econometric modeling, that to get the estimated models. So, basically we use matrix for a multivariate problem, but that does not mean that matrix application is always meant for multivariate problem. It can be also used for bivariate also. Okay. So, you can use matrix in the bivariate, you can use trivariate, or you can use multivariate, but the use of matrix multivariate is the more interesting, more meaningful, or you can say it has more utility. But it's very difficult to start with a multivariate problem and that to apply a matrix approach here. It's very difficult. So, what we have to do here, we have to take a very simple problem and we will highlight how matrix can be used to get the estimated models. Okay. So, that is our today's observations only. So, what we have to do? So, I will take a simple problems. Okay. So, the problem consists of like this: y is 1, 4, 3, 8, 9. Okay. So, then corresponding to y we have x constant to 0, 1, 2, 3, 4. Okay. So, that means we are taking a bivariate systems here. So, there is one dependent variable y and there is another independent variable x. So, we can regress or we can estimate by simple application of OLS techniques, which we have discussed long back. But my point is here how matrix can be applied to solve this particular problem, so that we can get the estimated equations. So, now in this particular structures there are two variables. So, one dependent and one independent, and the sample size is here just equal to 5. Okay. So, we are artificially we are keeping the system very simple, so that we can discuss very quickly. Otherwise, if you start with a very complex problem, it is very difficult to finish within this particular class timing. So, that is why we have taken a very simple problem, that to very small sample size. So, that our aim is here how matrix can be applied to get the estimated estimated econometric models. Okay. So, let us see here. So, as usual, so for this particular problem, so in the meantime it is not required to know what is exactly y, what is exactly x, and what is the theory behind y and x, whether y and x are related to each other. So, in the meantime we are just tracing the pure mathematics. So, that means with having y and x, how we will get the estimated model, that to beta 0 head and beta 1 heads, and then we have to test the significance of these parameters and the overall fitness of the model. That is the basic agenda. So, of course, we need theory, we need literature, so that we can justify properly or we can interpret properly the estimated model. But in the meantime, it is not required here. It is required when we will go for something else. Okay. So, in the meantime, we just apply the matrix and have the estimated model. That is our main agenda. Okay. So, for this, so let us assume that our simple model is y equal to x beta plus u. Okay. So, where y consists of y1, y2, y3, y4 and y5. Okay. y5. Okay. These are the concept, and this particular structure can be represented like this. So, x represents here obviously 1, 1, 1, and there are 5 observations, 4, 5. Okay. So, then 0, 1, 0, 1, then 2, 3, 4. Okay. This is x. That means what is exactly the structure? This is like this. Okay. So, what we are doing, 1, 1, 1, 1, 1, this is for beta 0, and for beta 1 the samples are x11, x21, x23, x41, x51. Okay, so this is x, and similarly y it can be represented like this. Y can be like this, 1, 4, 3, 8, 9. Okay, so this is y. Okay, so then we like to know what is beta. So beta is here simply beta 0 and beta 1. Okay, so now this is our models, matrix approach to bivariate econometric model. Okay, this is called as a matrix approach to bivariate econometric models. Okay, matrix approach to bivariate econometric models. So the y equal to x beta plus u, it's a very interesting. So if it is if the system is 2, then we can write y equal to x beta plus u. If it is 3, we can also write y equal to x beta plus u. If it is 4, the system consists of 4 variables, we can also write y equal to x beta plus u. Even the system is 5 variables, we can write y equal to x beta plus u. That means whatever shape you have, or whatever problem setup is all about, we will always represent in a unique format. That is the speciality of matrix approach. So that means y is simply equal to x beta plus u. However, when we interpret, or when we justifying the variable y, x, and you can say beta and u, that times it will highlight the details. For instance, if it is bivariate, then there are only 2 columns here. So if it is trivariate, then there are 3 columns here. If it is for variables, then it is another column you have to add it. So this is how you have to proceed further. So that means this is the basic setup here. So this is for bivariate. So once trivariate, then another row, another column. Then if it is for variable systems, then there is another row, like this it will continue. So similarly it will add one after another, beta 0, beta 1, beta 2, beta 3, beta 4. Okay, so by the way it will also increase continuously. So this is how the entire structure. So that means y is like this, x is like this, and beta is like this. So now we like to know the structure, how will we get the estimated model. So that means we like to know what is y head. Okay, y head equal to x beta head, y head equal to x beta head, x beta heads, where beta head equal to x transpose x inverse x transpose y. Okay, so this is our estimated structures. So forget about the variance of beta head and other things, because that will come later. So once we get the estimated model, then we will look into the significance of the parameter and overall fitness of the model. So that means our basic objective is here to get this beta head. So how do we get this beta head? Through this metric application only. That's all. Okay, so now we have x here. So x equal to simply 1, 2, 3, 4, 5. So 5 ones. Then 0, 1, 2, 3, 4. This is x. Okay, so then x transpose equal to 1, 1, 1, 1, 1, then 0, 1, 2, 3, 4. Okay, this is how the x transpose is all about. So that means we like to know what is x transpose x. First we calculate x transpose x. So x transpose x means, so this is 1, 1, 1, 1, 1, then 0, 1, 2, 3, 4. Okay, multiplied by 1, 1, 1, 1, 1. Okay, this is multiply then 0, 1, 2, 3, 4. Okay, this is how a complete structure. So now we have to multiply. So this is nothing but 1 into 1 plus this way it will connect like this. Okay, this will connect like this, this will connect like this, and this will connect connect like this. Okay, so that means 1, 1, 1, 1, and this and this. Okay, this and this. Okay, this and this, this and this, and finally this and this. Okay, so this is how the entire structure. So 1 into 1 plus 1 into 1 plus 1 into 1 plus 1 into 1. Okay, 5 multiplication 1, 2, 3, 4, then plus 1 into 1. Okay, so this is 1. So because it is 2 into 2, this is 2 into 4, this is 4 into 2. okay. So this is sorry, 2 into 5, and this is 5 into 2. So we will get simply 2 into 2, okay. So this is 1, so obviously there will be another one. So that means this particular 5 has to be multiplied with this one. So that means 1 into 0, okay, plus 1 into 1 plus 1 into 2 plus 1 into 3 plus 1 into 4, okay. So similarly, so this is how you have received. So now this, then this will be multiplied by this, and this will be multiplied by this, okay. So that means 0 into 1 plus 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 1, okay. So this is one structures. Then another is 0 into 0 plus 1 into 1 plus 2 into 2 plus 3 into 3 plus 4 into 4, okay. This is how the entire structure result. So now this is if we do simplify, this will be simply 5, and if we simplify this one, this will be simply 10, and if we simplify this one again, this will be 10, and if we simplify this one, this will be remains 30, okay. So now we will transfer. So that means x transpose x inverse x equal to simply 5, 10, then 10, 30, okay. So this is how the x transpose, okay. So we have received x transpose x is this much, okay. So similarly, we like to know what is x transpose y. So that means x transpose x equal to 5, 10, then 10, 30, okay. At a time we can finish these jobs. So that means we need beta head equal to x transpose x inverse into x transpose y. So we have now x transpose x. So we have not received x transpose x inverse. Let us first do the x transpose x inverse. X transpose x inverse. So which is nothing but, you know, matrix A by adjoint of matrix A by mod A, okay. This is adjoint of matrix A divided by mod A. So this is A matrix, okay. We like to find out the adjoint of that particular matrix and divide by value of that matrix. That is what the simple formula of inverse matrix, okay. So how do the so for that, here we have to know the cofactor and minor, etc. So I am not writing in detail, so I am just calculating the value only. So now if we will simplify this one, then it becomes minus 30, it becomes minus 30, no sorry, this is 30, 1 to the power 1, okay. So then this is minus 10, this is minus 10, and this become 30, okay. So divided by value of the matrix, this is 30 into 5 minus 10 into 10, okay. So this is nothing but 100, and this is 150, okay. So that means it is equal to 1 by 50 by 30 minus 10, then minus 10, 5, okay. This is the we can say inverse matrix, so inverse matrix of x transpose x inverse x, okay. So x transpose x inverse equal to 1 by 50, 30 minus 10, 5, okay. So that is the inverse matrix, okay. So now we like to know, if we simplify this one, then x transpose x inverse is equal to 30 by 50. So that means 3 by 5, this is 0.6, then this will be minus 0.2, then this is minus 0.2, then this is simply 0.1, okay. So this is x transpose x inverse. So similarly we like to know x transpose y. So we know what is x transpose. So x transpose, we like to know x transpose y. So what is first x transpose? So x transpose is here equal to 1 1 1 1 1, then 0 1 2 3 4, okay. This is x transpose, and we have to multiply it by y is how much? Y is the column vector here. So y represents 1 4 3 8 9, okay. So that means 1 1 1 1 1 0 1 2 3 4 multiplied by y is how much? It is 1 4 3, then 8 9, okay. So this is how the x transpose y. So we will simplify again. So that means this is 2 into 5, this is 5 into 1. So we will get 2 into 1 simply. So 2 into 1. So 2 into 1, this multiplied by this and this multiplied by this. So that means it is nothing but 1 into 1 plus 1 into 4 plus 1 into 3 plus 1 into 8 plus 1 into 9. Okay, so this is one row. Then second row is 0 into 1 plus 1 into 4 plus 2 into 3 plus 3 into 3 plus 4 into 9. Okay, so this is another row. Okay, so now if you simplify, then this will be coming 25 and 70. 25, this is nothing but 25 75. That means this particular sum is 70 and this particular sum is equal to 25. This particular sum is called as a 25. Okay, so now we'll just summarize. So we have y equal to 1 4 3 8 9, then x equal to 0 1 2 3 4. Okay, then x transpose x equal to 5 10 10 30. This is x transpose x. Then x transpose x inverse equal to how much? It is 0.6, then minus 0.2 minus 0.2, then this is 0.1. Okay, 0.1. so this is x transpose x. Then we need x transpose y. X transpose y is equal to how much? X transpose y equal to 25 70. So this is x transpose y. Okay, this is the summary of this particular system. So now we need to know what is beta head. So beta head equal to x transpose x inverse into x transpose y. Okay, so now x transpose x inverse is here, then x transpose y is here. So that means 0.6 minus 0.2 minus 0.2 0.1. okay, so this is one matrix. Another matrix is 25 70. okay, so this is order of 2 into 1 and this is order of 2 into 2. So obviously, so this will be crossed out. So ultimately the result of matrix should be 2 into 1, because we have beta head means it is nothing but beta 0 head and beta 1 head. So this is how the entire structures. Okay, this is how the entire structure. So we have to multiply again. So this multiplied by this and this multiplied by this. So obviously it is 0.6 into 25. Okay, plus minus 0.2 into 70. Okay, so minus 0.70. then another column will be minus 0.2 into 25 plus 0.1 into 70. okay, so this is another row. okay, so this particular structure will be coming equal to how much? It will be, if you simplify, then this is 0.6 into 25, so 6 by 10. okay, 1 by 1 point, this is how much? 63 150. okay, so 15. okay, then minus 70 14. okay, 14.0. so then this is minus 20. okay, no, 50. okay, 50. this is 50, then this is 70. okay, plus 70, 0.70 0.50. okay, so that means it is equal to 1 and 2. it is equal to 1 and 2. this is equal to 1 and simply 2. okay, this is how it's coming. So beta 0 head equal, that means beta 0 head equal to 1 and beta 1 head equal to 2. again we will summarize this entire result. So that means x transpose x, what we have obtained, x transpose x is equal to 5 10 10 30. Okay, then x transpose y equal to 25 70. Okay, then x transpose x inverse is equal to 0.6 minus 0.2, then minus 0.2 0.1. so this is x transpose x inverse. Then we have x transpose x into x transpose x inverse into x transpose y, which is coming 1 and 2. Okay, no, 1 and 2, so it's better so we will write 1 and 2 like this. Okay, so this is how the system. So now what is our beta head? So beta head equal to x transpose x inverse into x transpose y, so which is nothing but beta 0 head and beta 1 head. Okay, so which is equal to, that implies this is equal to 1 and 2. So that means the estimated equation will be so y head equal to 1 plus this is not required, 1 plus 2x. Okay, 1 plus 2x. So that means this is nothing but how we will write here. So that means it is beta 0 head plus beta 1 head x. So beta 0 head is 1 and beta 1 head equal to 2. So now we like to once you get the estimated model, then you have to go by as usual procedures to test the significance of the parameters, that to beta 0 head and beta 1 head, and again overall fitness of the model, that is R-square, and followed by F statistics. So now here we will not again go by beta 0 head separately and beta 1 head separately, rather we will get beta head direct value, then automatically it will indicate the significance of the parameters. So let's see here. So now to know the significance of the parameters, then once this is beta head. Okay, so we need to know variance of beta head. So variance of beta head equal to the variance of beta head, the formula is sigma square u x transpose x inverse. So this is the formula which we calculate for, you can say, variance of beta head. So now once you have variance of beta head, so then accordingly by the procedure you have to calculate the sigma squares. Then once you have the sigma square, then you have to multiply it with x transpose x inverse, then you can get to know the variance of beta. So accordingly you have to make a square root, you will get the standard error of beta head. So then you have to connect with the null hypothesis, ultimately you will get the t statistics. Okay, so let's see here how is the structure. So before going to sigma square summation x transpose x inverse, it's better so you have to first calculate this particular structure. So this is sigma square u square. So sigma square, where sigma square u is equal to summation u square by n minus k. Okay, n represents total number of observations, total sample observations, and this is k represents here total number of variables. Okay, so this total number of variables is here, only k represents here 2. Okay, so because 2 variables are there, only y and x, so n minus k. Okay, n minus k. So now we like to know what is summation u square. So summation u square is here. So that means sigma square u equal to summation u square by n minus k. So here summation u square equal to summation y square minus summation y head square. Okay, so what is summation y head square? So summation y square is here. Okay, summation y square equal to y transpose y. So this is how y transpose y minus n y bar square. So this is how the structure about n minus n y bar squares, and summation y head square equal to that is ESS. Okay, this is ESS, that will be beta head transpose x transpose y minus n y bar squares, okay, beta, okay, right, n bar y square, okay. Then summation e square equal to summation y square minus n square. So this is summation y square equal to explain sum square, that is residual sum square, that will be y transpose y minus beta hat transpose x transpose y. This is summation, yes, this is summation e square, this is summation y square, then this is summation y hat squares. So now we like to know what is, so then next step is you have to calculate summation y square, summation y hat square, summation y square. You see, since we have only simply y and x, so you can just put in the Excel sheet and you can calculate immediately by transferring into deviation format. This is all about in you can say original format. We can transfer into deviation format and you can get the answer. But here our aim is not to get the result immediately. Here our aim is how matrix can help you to get this result done. Okay, so that is our the structure. So that means once you have this particular estimated beta, so we have to find out the significance of the beta. Then obviously we have to find out the variance of beta hat, and for that we need to know sigma square u, and sigma, for that you need to know summation e square, summation y hat square, summation y square. So these are the formula which help you to calculate all these statistics. Okay, so that means what we have to do now, so we know what is y and we know what is y hat. So accordingly we have to calculate. So summation y square is nothing but y transpose y. Okay, means we have to multiply, just like we have got here e transpose e. So similarly y transpose e we will get it here. So similarly summation y hat square equal to y hat transpose, you can say y. So this is how the entire structure can be built. Okay, so let's see how we will calculate summation y square first. So summation e square we have to calculate like this. So what you have to do, so let's say y is there. So y is how much? So y is 1 4 3 8 9. Okay, so this is y structures. Okay, this is y structures, and we like to know y bars, y transpose equal to y transpose equal to, then this is 1 4 3 1 4 3 8 9. Okay, 8 9 1 4 3 8 9. Okay, so this is in square matrix, this is square matrix, this is column matrix. Okay, so now we like to know what is y transpose y. So y transpose y is nothing but 1 4 3 8 9, then multiplied by column vectors 1 4 3 8 9. Okay, so this is how will give you summation y squares or y hat y. So y hat y transpose y. Okay, y transpose y. So now this will be equal to 1 into 1, okay, plus 4 into 4 plus 3 into 3 plus 8 into 8 plus 9 into 9. Okay, so this is 1 into 5, and this is 5 into 1. So the matrix order we can receive 1 cross 1 only. So this is nothing but, if you simplify, then 171. So that means summation y square equal to 171. So similarly we like to know y hat square. So for that we need to know y hat. So y hat equal to actually x beta hat. So y hat equal to x beta hat, but we have beta hat and we have also x, so we can again multiply. So what is x here? So y hat equal to x beta hat. So x beta hat means what is x here? So x is here 1 1 1 1 5 numbers. Okay, so then 0 1 2 3 4, then multiplied by beta hat equal to simply 1 and 2. So this is 5 into 2, and this is 2 into 1. So we will have the order 5 into 1. Okay, we will have the order 5 into 1. So okay, so how we will do that? So okay, we will find out here. So we will find out here. So this is nothing but, so we like to know y head. So y head equal to 1 2 3 4 5, then this is 0 1 2 3 4, then multiplied by 1 and 2. Okay, so that means 1 into 1. Okay, so this is 1, then 1 into 1 plus 0 into 2 plus 0 into 2. Okay, so this is first element, then 1 into 1 plus 1 into 2, then 1 into 1 plus 2 into 2, then 1 into 1 plus 3 into 2. Okay, then 1 into 1 plus 4 into 2. Okay, so this is the y head. So you will if you simplify, then you will get this is nothing but 1, this is nothing but 3, this is nothing but 5, then this is nothing but 7, and this is nothing but 9. Okay, so this is y head, this is y head, but we need y head transpose y, y head transpose y. So this is y head. Okay, so y head transpose means, so this will be like this: 1 3 5 7 9, 1 3 5 7 9. So we like to calculate y head transpose y. So now y head transpose y is nothing but 1 3 5 7 9. Okay, so this is 1 into 5 order. Okay, 1 into 5 order, 1 into 5 orders, then multiplied by y. What is y here? So y is here 1 4 3 8 9. Okay, so this is y. Okay, so this is the order of 5 into 1. So 5 cancel, so ultimately this has to be considered. Okay, so that means we will get 1 into 1 matrix. So for that we have to 1 into 1 plus 3 into 4 plus 5 into 3 plus 7 into 8 plus 9 into 9. Okay, 9 into 9. So that means this is the completed. So this is 1, this is 12, this is 15, this is 56, this is 81. So if we will make a sum, then it will be coming 165. Okay, so this is 165, 1 upon 1. Okay, this is y head transpose. Similarly we like to know, so now you get summation y square. We have just calculated summation y square here. The summation so this is summation y square, and this is summation y square. So this is summation y head square. So we like to have again summation e squares. Okay, summation e square. So what is e? So we like to know e first. So e equal to y minus y head. Okay, so what is y head here? So y head 1. Okay, y head is 13579. Okay, so we will formulate like this. So y equal to, what is y here? So y is 1 4. Okay, 1 4 3 8 9. Okay, so then y head minus y head. What is y head? Y head equal to 1 3 5 7 9, which just receives y head equal to x beta head. Okay, beta head y head equal to x beta heads. Okay, which means we have to multiply the x vector with the beta head, then you will get the y heads. Okay, just like this is y head in transpose. So obviously 1 3 5 7 9 will be in a column shape. So now this is 5 into 5 cross 1, this is 5 cross 1. So obviously subtraction can be possible. So that means we will get the e is nothing but, error is nothing but 0 1 minus 2 1 0, because 1 minus 1 0, 4 minus 3 1, then 3 minus 5 minus 2, 8 minus 7 1, then 9 minus 9 0. So this is e component. Okay, this is e component. So this is e component. So but our requirement is e transpose e. Okay, so now we have e equal to 0 1 minus 2 1 0. This is E component. So we like to calculate E transpose. So E transpose equal to 0 1 minus 2 1 0. Okay, so this is E transpose. So now we like to know E transpose E. So E transpose E, E transpose E means 0 1 minus 2 1 0 multiplied by 0 1 minus 2 1 0. Okay, so this is another structure. So now this is 1 into 5 and this is 5 into 1. Okay, so obviously we have the system 1 cross 1. Okay, so 1 cross 1, so that means it is equal to 0 into 0 plus 1 into 1 plus minus 2 into minus 2 plus 1 into 1 plus 0 into 0. Okay, so this is of 1 into order. This is 0, this is 1, this is 4, this is 1, this is 0. So that will be coming on actually 6. Okay, that will be coming actually 6. So now see the moment, we will just simplify all these structures. So that means our E transpose E equal to 6, then Y head transpose Y is equal to 165, then Y head Y transpose Y is equal to 171. Okay, let's check it here. So because this is nothing but TSS, this is nothing but ESS, and this is nothing but RSS. Okay, this is nothing but RSS, but by default we have TSS equal to ESS plus RSS. Okay, so that means total sum square equal to explained sum square plus residual sum squares. So that means if you put here, you just connect here. So this is 171, so that means 171 is equal to 165 cross 6. So this is equal to 171. So that means this and this are equal. So this system is okay. Okay, that means we are in the right track. Okay, so now this is this is RSS, this is ESS, this is TSS. Okay, but we need ESS only, because sigma square equal to summation E square by n minus 2. Okay, so that means this is 6. Okay, n minus 2, because k equal to 2 here. So obviously 6 by n is 5 here. So 5 minus 2, so this is 3. Okay, so that means sigma square equal to 2. Sigma square equal to 2. So the moment you will get sigma square 2, then obviously, okay, let's see here. So see, okay, so this is 6. So r square will be coming. So that means sigma square equal to 2. So now variance of beta beta head equal to how much? Sigma square u x transpose x inverse. Okay, what is x transpose x inverse? Let's see here. So x transpose x inverse, so this is x transpose x inverse. Okay, this is x transpose x inverse. So now we have to write here. So that means sigma square u equal to 2 here, then x transpose x inverse x transpose x inverse. Okay, so that means it is multiplied by 0.6 minus 0.2 minus 0.2 into 0.1. Okay, this is how the entire structure all about. Okay, so this is variance of sigma square u2, and this is x transpose x inverse. Okay, so now 2 has to be multiplied with this one, so we will get the variance of beta head. Okay, variance of beta head. Okay, variance of beta head. So now accordingly, so this is this is in fact is a transpose, so there is no point to write it here again. Transpose x inverse into x transpose y. Okay, variance of beta head equals sigma square x transpose x inverse. Okay, so now we have to calculate this value. So this is nothing but 2. Okay, so this is how the variance of beta head has to be calculated. Okay, so now this is one part of the story. So that means what we have received here. So our model will be our model will be like this. So y head equal to 1 plus 2x. So that means beta 0 head equal to 1 and beta 1 head equal to 2. Okay, beta 1 head equal to 2. So now we need to know whether beta 0 head is significant or beta 1 head is significant. So that means we like to calculate t beta 0 head. T beta 0 head equal to accordingly we have to set the null hypothesis. Null hypothesis such that beta 0 head not equal to 0. No, okay, it will be equal to 0, and against the alternative hypothesis beta 0 not equal to 0. Okay, this is equal to 0. So that means beta 0 head divided by standard error of beta 0 head. Okay, standard error of beta 0 head. So similarly we have to calculate variance of beta head. That will be single figure. The moment you will get this multiply, then obviously you will get this value. So similarly t beta 1 head is equal to beta 1 head by standard error of beta 1 head. This is beta 0 head. Okay, standard error of beta 1 head. Okay, so this is calculated statistics, and you have to compare with the tabulated statistics with respect to this degrees of freedom n-2. Then you can get to know whether it is statistically significant or not statistically significant. Okay, so this is first part of the story, that is with respect to significance of the parameters. Okay, so the moment you know the significance of the parameters, obviously there must be definite conclusions whether beta 0 is significant or beta 1 is significant, or you can say both are non-significant, or vice versa, one is significant, another is not significant. Okay, so means by the way, in that particular process you get to know whether this particular item is statistically significant or not. Okay, so now what you have to do, so you like to know the other part of the story, that is overall fitness of the model. So overall fitness of the models, so that means once you have estimated models y equal to 1 plus 2x, so that this y head equal to 1 plus 2x, which we have just now received. So that means this is nothing but beta 0 head plus beta 1 head x. So that means beta 0 head is equal to 1 and beta 1 head equal to 2. So obviously, so you like to know t of beta 0 head and t of beta 1 head. Okay, so this is how you have to obtain. Okay, so then you check it whether statistical significance or not. So that means this is first part of the model, that is significance of the parameter, all right. So the second part of the model is the R-square, that is overall fitness of the model, overall fitness of the model. So what is R-square? R-square is here ESS, the ratio between ESS by TSS. What is ESS here? So ESS is here, how much ESS we have calculated. So just now here, okay, so this is here ESS. So no, this is okay, this is ESS, this is ESS here. So ESS is 165, so this is equal to 165. Then this is TSS is equal to 171. Okay, this is 171. So this is R-square value, R-square. So that means if you put it here, so the calculation will be like this. So just 1 minute here, 1 equal to 165 divided by 171. Okay, so this will be coming 0.965. So it will be coming 0.965. So means R-square value is 0.965, or otherwise, or it is nothing but 97%. If 97% means the reliability of the model is very high. That means the overall fitness of the model is very high. Since it is very close to 1, so that means this model can be used for forecasting or policy use. But in the same times, we have to check whether these parameters are statistically significant or not. Okay, so the moment it will be statistically significant, both the parameters, then obviously this R square can be valid. Still it is doubtful, because in a bivariate system, if you are getting high and high R squares, then obviously it may be criticized, because mostly if the multivariate system is there and R square value is high, then it can be justified. But here in this bivariate system, even if parameters are statistically significant, still it is doubtful case until unless you clarify that no other variables are significantly influencing the system. Still, if you are getting like these systems, then you have to find out what are the other variables which can influence this model. Then you enter and you check it whether the model parameters or model reliability will be getting affected. If it is not, then you can say that this model is absolutely okay with you. Okay, this is R square. Similarly, we will get adjusted R square. Adjusted R square equal to 1 minus R square into n minus 1 by n minus k. Okay, so this is n minus k. Okay, so now 1 minus r means 0.965. so this is 35. Okay, this will be coming 0.35. so 0.35. okay, 0.35, right? 0.35. no, it's a 0.97 means it's a 0.035. obviously 0.35. let's see here, 0.965, 0.35. so 0.09. okay, so this is 1, right? Correct. so 0.035 into n minus 1. n minus 1 is n is 5 here, so this is 4 divided by n minus k. 5 minus 2, this will be 3. okay, so that means 0.035. so equal to 1 minus 9673, which is equal to 0.035. okay, this is equal to okay, this is equal to E2 multiplied by 4 by 3. okay, 4 by 3. so 4 by 3, then it will be coming 0.46. so 0.46.8. so it is equal to 1 minus this much. okay, so this is becoming 0.95. so this will be coming 0.953. so that means R square equal to 0.965 and adjusted R square equal to 0.953. so there is a difference, and that difference is mostly because of the adjustment of variables and the number of sample size. That means mostly it is with respect to degrees of freedom only. So obviously, but adjusted R square is the more reliable component which can test the reliability, okay, or best fitness of the model. So now this is but still we are not confident whether this particular model is absolutely significant, because we have received just R square, and that has to be again statistically significant. So for that we need to have F statistics. So then that means we need to know what is F statistic here. So F statistic is here the ratio between ESS by RSS, but ESS we have already calculated, that is 165 divided by RSS. RSS is just coming 6. okay, 6. so that means 165 by 6. so this is equal to 165 divided by 6. okay, 27.5. so it will be coming 27.5. so R square is 27.5. so there is enough chance that this particular structure is highly statistically significant. There is no doubt about it. If you are getting high and high R square, then obviously F statistic will be very high, because F is derived from the R square only. You see here, R square is nothing but since F is equal to ESS by TSS, you just RSS, you just divide TSS in both the sides. So that means ESS by TSS divided by RSS by TSS. okay, so it will be, this is R squares followed by k minus 1, and this is followed by n minus k. okay, so this means R square by k minus 1 divided by 1 minus r square, 1 minus, because RSS is the ESS minus TSS minus ESS. So TSS by TSS equal to 1, then ESS by TSS again equal to r square. So 1 minus r square by n minus k. So that means there is enough possibility that when it is justified that if r square is substantially high, then obviously f will be substantially. If r square is substantially low, then f will be substantially low. So that means there is a huge connection between r square and f. The significance of the f depends upon the value of r squares. If r square is high, then there is enough chance that f will be statistically significant. If r square is very low, then there is enough possibility that the f will be not significant. Okay, so that means it is very closely connected to each other. So now if we summarize all these details, then finally the estimated model will be y hat equal to 1 plus 2x and r square equal to here how much r square equal to here 0.965, then adjusted r square r square equal to 0.953, and f statistic is equal to simply how much 27.5. okay, so this is the second part of the reliability. Okay, so that means this is overall fitness of the test. Okay, so that means we are now come to conclusion that metrics can be applied to estimate the bivariate model. It can also helpful for estimate the trivariate model, and it can also helpful for estimate the multivariate model. So that means it is just like the system of old wine in a new bottles, nothing new. So there are several ways we have to estimate the model and get the estimated model, and followed by the checking of significance of the parameter and overall fitness of the model. But of course sometimes you must have sound knowledge, means various techniques, various methods, various tools through which the estimation can be possible. It's not it is not suggestive that you have to always know one technique or one tools or one path through which you will get the job done. So you should know various techniques, various tools, and various methods through which how you have to receive the estimated models. Till now we are discussing about the application of OLS technique only. Even if in this matrix approach also we are transferring the system into matrix. Ultimately we are differentiating with respect to the corresponding parameters, but that is nothing but the application of OLS again. Methodology wise you can apply also various other techniques like GLS technique, WLS technique, maximum likelihood estimate technique. So many other methods are there. We can get the estimated models, but we will discuss later how GLS and WLS or maximum likelihood estimator can be applied and can get the estimated model. Till now we are in a position that there are various ways we have to get the estimated model. So now one part of the econometric modeling is over here. So now in the next class onwards, so we assume that there is the estimated models. So once you have the estimated model, what are the things we have to look, and what are the things we have to do further to get the model best fitted, and for means we have to look the model should be very best for forecasting use and for policy use. So for that the job is not so simple. The complexity will be more interesting here, because we have to look various aspects of estimated models before you use for, you can say, forecasting and policy use. So when we look for best models with respect to forecasting and policy use, so we have to compromise lots of things. We have to go through various aspects. So sometimes one will be very much helpful for you, and on the same time other will not helpful for you. So we have, with this type of shortcomings, that means sometimes you are in the gain position, you are in the loss position. So we have to find out a balanced approach through which the model can be judged as a best models and can be used for forecasting and policy use. So we will discuss in details in the next class. So till now we have to close this chapter here. Thank you very much. Have a nice day.